Hello everyone. So today onwards we will start a new series through which we will learn a concept through some questions. Okay. So in this video I have taken up a question that will help you to understand how inductor behaves and how to deal with some complex transient circuits, and also you'll get some understanding in that. Okay. So here you can see a circuit that has two inductor L1 and L2, and the initial current of the inductor L1 is 2 ampere and initial current of inductor L2 is 4 ampere. And you can see there is three switching instants, three switches basically, here, here and here, right? So three switches you can say. And at t equal to 0, the switching action is happening, like the switch is moving from one position to another position, and you have one external circuit, and the voltage across external circuit is given as 12 e to the power minus t for t greater than equals to 0. You need to find out the I of t for t greater than equal to 0 and energy stored in L1 and L2 at steady state. Okay, so if I just show you what was the initial inductor, let's say this is your inductor. So initially inductor was just short circuited, both the inductors, okay, and the inductor current was for L1 it has 2 ampere, so 2 ampere was flowing in this path and 4 ampere was flowing for L2. Okay, so like that it was flowing, and at t equal to 0 you change the switching, and you can say that switching position, and you have to calculate the response. Okay, basically both the inductor will store some energy, okay, before t equal to 0 you can say, and just after t equal to 0 that energy will start delivering into the external circuits. Okay, we will see what will happen. So now I will draw the equivalent circuit for t greater than equal to 0. At t greater than equal to 0, in that case what will happen, both the inductor will come parallel. Okay, so you can cross check from the question, and it will be just parallel to the this, you can say, the external circuit, and you have given a voltage here v of t 12 e to the power minus t. So this is your L1, this is your L2, and L1 is 3 Henry and L2 is 6 Henry. 3 Henry, 6 Henry, and there is a this switch, basically we are opening the switch, so it don't have any kind of effect, so I can just omit it. And the initial currents are 2 ampere and 4 ampere, right? So let's say this current is I1 of t, this current is I2 of t, and this total current is I of t. Okay, and the initial current I1 of 0 is simply 2 ampere, and for the inductor 2 it is 4 ampere. Now we will calculate the current I1t. Now see, the voltage are parallel. Okay, and you can see for this particular inductor L1 and L2, the currents are leaving the positive terminal. Okay, and that's why you need to take one negative sign when you are writing the voltage across inductor. Okay, so what is that I will show you now. So let's say for inductor L1, v of t, this is the inductor voltage, and these are parallel, right? So these three will parallel, so same voltage will appear. L1 di1 by dt. This particular equation is only valid if current enters in the positive terminal of inductor voltage. But here you see the positive terminal is here, current is leaving the negative, current is leaving the positive terminal I1t. So to compensate that, you have to give a negative sign here. Okay. Yeah. Now proceed. 12 e to the power minus t, and L1 is 3 Henry is equals to minus di1 by dt minus 4 e to the power minus t dt is equals to di1. Now do the integration. Let's say at t equal to 0, my I1 initial current was I naught, so it is given, right? I naught 0, I1 0, it is 2 ampere, and at any given time t, I want to see the current I1 of t. So this is how you have to put, and if you do the you solve the integration, you will get e to the minus t minus 1 is equals to I1 of t minus 2. So 4 e to the power minus t minus 4 plus 2 is equals to I1 of t. Now I1 of t simply 4 e to the power minus t minus 2, right? So this is your equation number 1. In this equation, if you put t equal to 0, you will get I1 of 0 is equals to 2 ampere, which is valid, right? Which is true because we started initial current with 2 ampere, so it is true. And at t tends to infinity, the inductor current flowing through the inductor 1 is simply, if you put t tends to infinity, you will get minus 2. Okay. Now come to the inductor 2, L2. Same, v of t is equals to minus L2 di2 dt minus 12 e to the power minus t by 6 is equals to di2 by dt minus 2 e to the power minus t dt is equals to di2 minus 2 0 to t e to the power minus t dt is equals to, initial current was 4 ampere, right? So 4 to I2 of t di2. So 2 e to the power minus t minus 1 is equals to I2 of t minus 4 is equals to 2 e to the power minus t minus 2 plus 4 is equals to I2 of t minus t plus 2. Okay. Now from this equation, if you see the I2 of 0, you will get 4, which is valid because initial current must be 4, and at steady state the current is 2 ampere. Okay. So what is happening, and if you see, if you calculate the total current I of t is equals to I1 of t plus I2 of t, that is simply 4 e to the power minus t minus 2 plus 2 e to the power minus t plus 2, you will get 6 e to the power minus t. So let's say this is equation number 3. So if you see the initial current I0 is simply 6 ampere, which is valid because one is delivering 4 and another is for delivering 2. So that summation is 6 ampere, and at steady state the current is simply 0. So what is happening at steady state at t tends to infinity, this is your inductor 1, this is your inductor 2, and this is your external circuit, and this current is simply become 0 ampere, this current is minus 2 ampere, this current is simply 2 ampere. So basically I can show this minus 2 ampere is in another direction as a plus 2 ampere. So this is 2 ampere, and this 0 ampere current is flowing into the external circuit. So just I can simply remove this particular section. Okay. Now you have 6 Henry here. You have what? 3 Henry here, right? This 2 ampere current will it will flow in this 2 inductor. So at steady state, this particular set will have some energy. So if you see the energy stored at t equal to 0, so that is E1 0, that means energy stored at inductor L1, and energy stored at inductor L2 at t equal to 0, which is simply half 3 into 2 square plus half into 6 into 4 square, right? It was the 2 ampere, 4 ampere, the initial currents. So 3 6 3 6. So this is simply half Li square, right? Half Li square. So 6 plus mm, 3 into 16, right? 6 plus 48, 54, right? 54 joules. So this is the initial energy. Now at steady state, what is happening? At steady state, you can also calculate the energy stored in both the inductor. So half into 3 into 2 square, both the inductor has same current, and half into 6 into 2 square. So it will be 6 plus 12 is equal to 18 joules. So basically at steady state, it has this energy, and initially this two inductor has had this 54 joules. So you can also calculate the energy lost. So you can see from this particular equation, this analysis, like in all the cases, even though uh, one can think like, okay, I have moved the switching position from one instant to another instant, then maybe my inductor will entirely discharged. Like one can think like this two inductor L1 and L2 has had some initial energy. The moment I connected this two inductor some external circuit, maybe my inductor will totally be discharged. But this is not the case, okay, because the voltage is given across this external circuit, which is 12 e to the power minus t. In that case, what will happen? Your inductor, how it will behave, like that will be decided by this voltage. But let's say instead of this external circuit, you had only kind of external resistance here, kind of just a external resistance circuit. Okay, in that case, what will happen? The energy stored in the both the inductor will total energy will be dissipated in the resistor. So in that case, your inductor, you can say, there will not be any kind of energy. Okay, but in this case, what is happening? It is delivering some energy to this external circuit. At the same time, it is also it is also having some energy in the inductor at a steady state. So this is the concept. Like that will depends on the external circuit, how the circuit is. See, the response it says like 12 e to the power minus t. So you cannot judge what is the component that is there in the external circuit. Okay, yeah. That is the thing that I wanted to discuss. But still, if you have any doubt regarding this discussion, maybe you can ask me in the uh, chat section. Yeah, thank you.